Example 4.18. Answer the following questions. A. A magnetic field that varies in magnitude from point to point but has a constant direction, east to west, is set up in a chamber. A charged particle enters the chamber and travels undeflected along a straight path with constant speed. What can you say about the initial velocity of the particle? So when the charged particle is moving undeflected, it implies that the magnetic force is not acting on it. Now, we know this thing. When any charge Q is moving in the magnetic field B with velocity V, the force acts on it, that is QVB sine theta. Means if the speed and magnetic field are either parallel or anti-parallel, then theta will be either 0 or pi. In that case, the force will be 0 and the particle will move undeflected. So initial velocity or speed, we can say that should be parallel or anti-parallel to B. Question B. A charged particle enters an environment of a strong and non-uniform magnetic field, varying from point to point both in magnitude and direction, and comes out of it following a complicated trajectory. Would its final speed equal the initial speed if it suffered no collision with the environment? So here see, if the magnetic field that is uniform or non-uniform, whether it is changing point to point both in magnitude or direction or not. But when any charged particle is moving in the magnetic field B with velocity V, the force which acts on the particle, that will be always perpendicular to V and B, because direction of F, that is in the direction of V cross B. Now when force is perpendicular to the velocity, then in that particular case, the work done, that will be always 0. In standard 11th, we studied this thing. And as per work energy theorem, when work done that is equal to 0 means change in kinetic energy, that is also 0. So if change in kinetic energy, that is 0, means the speed remains constant. So we can say the final speed, that will be equal to initial speed. Clear? Now see the particle that is electron, that is negatively charged particle. And we know this thing, when negatively charged particle is under the effect of the electric field, the force acts on it in the opposite direction of electric field. So here, due to electric field, the force on electron, that will be towards the north. It implies that here magnetic field should be applied such that the force on electron due to magnetic field, that should be in southward direction. Okay. Now, your force, that should be southward. So here, if we think about the direction of magnetic field, now suppose direction of the magnetic field that we take vertically upward, then as per Q into V cross B, if you rotate right-handed screw from V to B, then your thumb will point northward. But that is for charge Q. Here electron is negatively charged particle. So the force, that will be in opposite direction. So if your magnetic field that is vertically upward, it implies that perpendicular to the plane of paper in outward direction, then the electron will experience the force in downward direction. And now if these two forces due to electric field and due to magnetic field are balanced, then it will move undeflected. Clear to all of you?